Today we are with our new topic, that is Maxwell's equations. Maxwell's equations. Maxwell's equations. In our topic of electromagnetic waves, we will study about Maxwell's equations. He had given four equations. Okay, four equations. So in Maxwell's equation, the first equation was from Gauss theorem. Do you know Gauss theorem? The line integral of closed integral of electric field through a unit surface area is 1 by epsilon naught times the total charge enclosed. This is from the Gauss theorem. From this theorem? From the Gauss theorem of electrostatics. Gauss theorem or Gauss law of electrostatics. Gauss law of electrostatics. This is from the Gauss law of electrostatics. The closed line integral of electric field with respect to the small area element gives 1 by epsilon naught times the total charge enclosed. This is Gauss theorem. Next, Maxwell had given the closed line integral of B with respect to the small element dl, length element dl is mu naught times the total current enclosed. So what is this total current? We in our previous lecture taken the value of I. I is nothing but IC plus ID. I is what? IC plus ID. Understood? I is equal to IC plus ID. So what this ID is equal to? Epsilon naught times d phi by dt. But I is equal to IC plus epsilon naught times d phi e by dt. Very good. Next, we will substitute these values of I at the place of I. So these values will be substituted in the place of I, and we will get this expression. The total magnetic field, line integral of total magnetic field with respect to a small length element dl, when a magnetic substance is placed in a magnetic field, so the total line integral of this field is equal to B dl is equal to mu naught times IC plus ID. Mu naught times IC plus ID. Give it as first equation. So what is the value of IC plus ID? Total current is I is equal to IC plus ID. And on the next step, we will get IC plus D. Okay, that's the expression. We will substitute the values in our expression. B dl is equal to mu naught times IC plus epsilon naught times d phi e by dt. That's the expression of Maxwell's second equation. Some element of length dl, we had considered some length dl. We are integrating this dl up to so on, up to n terms. In some magnetic element, the total magnetic field generated is B. B is the total magnetic field. Okay, so the total line integral gives mu naught times IC plus ID. We had studied this expression in our previous chapter of magnetostatics. Okay, so now